Okay, so this will be for the second day on the parabolas. I want to go back through the definition. Parabola is the set of all points in a plane that are, it's the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. So all the points on the parabola are equidistant from the focus and the directrix. Okay, so we defined that yesterday. Okay, now I'm going to add to it. The line segment through the focus of the parabola and okay, it goes through the parabola and perpendicular to the axis of symmetry is called, this has a special name, it's called the lattice rectum. Okay, the endpoints of the lattice rectum lie on the parabola. Okay. Now I want to go through a picture like we did the other day. Okay. And it won't look exact because we're just sketching it. Okay. But if I have a parabola, okay, the point at the bottom of that parabola, that is your vertex. They will usually use V for vertex. Okay. The vertex is on the axis of symmetry. In this case, any vertical line is going to be x equals. Okay. So that's your axis of symmetry. The foci point lies what I consider on the interior. Okay, so it's, say, somewhere in here. That is the foci point. And a parabola is only going to have one focus. Okay. The directrix is equidistant from the focus to the vertex and vertex to the directrix. So this distance here has to be the same as the distance to the directrix. And the directrix in this case is going to be parallel. Okay. So it's going to be y equals a number. The axis of symmetry is vertical, it's going to be x equals a number. Now, if we drew this correctly, every point on the parabola is equidistant from the focus to perpendicular to the directrix. Let's label this one the directrix. So this would be congruent to this. no matter where I draw that line, if I go from the focus to a point on the parabola, from a point on the parabola perpendicular, okay, these are always congruent. Those two distances have to be congruent. Okay, then the author also defined a what they call the lattice rectum. It goes parallel to the directrix. Okay, it's a line segment. It's perpendicular to the axis of symmetry, and it goes through the focus. Okay, so it goes through the focus. It is perpendicular. Okay, so this would be a right angle right here. And the points, the endpoints of the lattice rectum are on the parabola. So that green line going across through the focus, okay, that whole thing is the lattice rectum. Okay? And what the author is trying to get you to see on the assignment 5 through 10 is that if you figure these values, it will help you draw the graph of your parabola. Okay? I think we've got it all labeled. Yep. Okay, then the author has a table in the book, and I want to put it in your notes. So, whoops, I don't want that color. We need 3 columns. The first row is called the form of the equation. Okay, and the standard form, they said, was y equals a times the quantity x minus h, quantity squared, plus k. If it's y, your clue that it's going to graph a parabola is it's a y to the first and an x squared. Okay, or it's an x to the first and a y squared. So if you have x equals a times y minus k, quantity squared plus h. If it's an x to the first and a y squared, it's going to open left or right. Okay, if it's a y to the first and an x squared, it's going to open up or down. Okay, so we need to look at both equations. Okay, the first thing with that form, you can get the direction of the opening by sight. Okay, if it's y to the first and an x squared, if a is greater than 0, it's going to open up, and we're just going to use the symbol open up. If a is less than 0, it's going to open down. Okay, if it's an x to the first and a y squared, if a is greater than 0, it's going to open to the right. If a is less than 0, it's going to open to the left. So if you had a negative a value, it's going to open to the left. Okay, then in this form, the vertex. In both of these, the vertex is hk. hk. But you have to look carefully in the equation for this one. This has to be a minus sign in this equation, and then you read your h. So if that happened to be plus 7, then my h would be a negative 7. And my k, this has to be a plus sign in front of the k. So if it was minus 15, then that's like plus a negative 15. Okay, and you read your hk from that. The difference on this is, look at where the h is. The h is on the right outside, and the k is on the inside. But the vertex on both of them is hk. Okay. Then the next thing the author covers is the axis of symmetry. If it opens up or down, your axis of symmetry is a vertical line, and it's x equals. X equals what number? Well, it's x equals h. It's x equals h. And it will be a vertical line like this, and usually they dash it. On this one, it's going to be y equals and it's the number inside, so it's y equals k. So it's going to be axis of symmetry. Y equals a number is a horizontal line. Okay, then the next thing the author goes through is the focus point to find the equation, and it's basically you have to sub in. You got to figure out what's the h up above, and if the focus is an ordered pair, the x value is h. The y value is k plus 1 over 4a. 1 divided by 4a. So basically, once you figure out your three letters, your h, your k, and your a, you just sub into that. And on the other form, the x value is h plus 1 over 4a, and the y value is k. You just basically sub in and you get your focus. The directrix on this form, it's y equals. The directrix has to be horizontal in this form, so it's got to be y equals a number. It's y equals k minus 1 divided by 4a. And you figure out what that number is. Okay, on this form, it's x equals h minus 1 divided by 4a. So on this one, the directrix, the directrix is a horizontal line. This one, the directrix is a vertical line. Okay, okay, and the last thing, the length of the lattice rectum, that line that goes across through the foci or focus point, and the two endpoints are on the parabola, and it's perpendicular to the axis of symmetry. The length is the absolute value of 1 over a. It has to be absolute value because it's a length. And on both these, they are the same. It's the absolute value of 1 over a. Okay, now I'm going to take you through two examples, and this is what I want you to do on the homework. You have to go back through problems 5 through 10. Okay. Okay. On the directions, find the vertex, axis of symmetry, how it opens, the focus, the directrix, length of the lattice rectum, and then graph the parabola. Okay, here's the equation. X equals 1/4 y squared plus 1/2 y plus 13/4. Okay, this is not in the right form. Okay, this is like general form, and we need the standard form. So first thing I would do is I would slide that constant term down out of the way. Just leave a little space there. Then factor out the 1/4. So it's like divide that first term by 1/4, divide the 1/2 by 1/4. So 1/2 divided by 1/4. Invert this fraction. So you'd end up with 2, right? So you get y squared plus 2y. At that point, you should be able to, if I multiply this back, I'd get the original 1/4 y squared. If I multiply this back, I'd get 2 over 4, which is 1/2. And that's what I want. Okay, now you have to take half the coefficient of that linear term, 1, and add 1 squared. But what did I really add? I really added 1/4. So to balance it, I got to subtract 1/4. Okay? Everybody okay with that? Now factor that back. Leave the 1/4 out front. We're going to factor it back into the square of a binomial. Y squared is a perfect square of y. 1 squared is a perfect square of 1. This tells you the sign inside's plus. So you square that. It's like y plus 1 quantity squared. Okay, and then, yeah, so that'd be 13/4 minus 1/4 would be 12/4 would be plus 3, right? Plus 3. Okay, in that form, and I always write the equation right below it. It's easier. So if you said x equals, if we went back to that table, it's a times y minus k quantity squared plus h. Okay, and we're going to answer the questions that they asked for. First, they asked what is the vertex. It's hk. So in this form, h is 3 and k is -1, right? You got to be careful. That formula has, this is a negative sign. This has to be negative. So instead of plus 1, it's like minus a -1. Okay, so here's one answer. 3 -1. Okay, it wants the axis of symmetry. And the axis of symmetry is y equals a number. Y equals, go back, it's y, axis of symmetry. It's y equals, in this form it's y equals k, right? So y equals -1 is our, yeah, it opens to the right or left, yep. Okay, and that's the next thing. How does it open? A is 1/4. Okay, A equals 1/4. A is greater than 0, so it opens to the right. A is positive, so it opens to the right. So that's the other answer. And be nice to your grader. They ought to be able to go through these one at a time. Okay, then the next thing it asks for is the focus point. Okay, the formula. The formula for the focus. Yep, h plus 1 over 4a, and then comma k. So our h is 3. Our a is, so it's 4 times 1/4. That's a fourth of 4. 1. And our k is -1. So this would be 4 plus 1, or sorry, 3 plus 1, which would be 4, -1. So your focus point is 4, -1. The directrix, okay, the directrix is x equals h minus 1 over 4a. Our h is 3 minus 1 divided by 4 times a 4. So that's 3 minus 1. So x equals 2. That is our directrix. X equals 2. Okay, and the last is the length of the lattice rectum. Okay, and it is the absolute value of 1 over a. So absolute value of 1 divided by 1/4. Invert and multiply. So 4 should be the length of the lattice rectum. Okay, and then the very last thing you do is you take that information and graph it. Okay? Before, I would have said make a table of ordered pairs. Okay? But for right now, we're going to do just use what we just calculated. Okay, so a little sketch. Okay, the very first thing, the vertex is 3, -1. So go to the right, 3, and down 1, and plot a point. That is your vertex. And we know it opens to the right from there. Y equals -1, okay, is your axis of symmetry. So y equals -1, there's a line going through. Okay, the focus point is 4, -1. So we need to go over 1 and down 1. So this is the focus point. Okay. The directrix is x equals 2. X equals 2. And that should make sense. If you look, this is 1 unit away, the focus is 1 unit away, the directrix is 1 unit away. Okay? Okay, then we've got the focus. The lattice rectum is 4. Okay, it goes from the focus, and it's 4, so it's got to be 2 up. So we got to go up 1, 2, and put a point, and down 1, 2, and put a point. Okay, so I should know, and it opens to the right. Okay, and that's what they're asking for the graph. Okay. Okay. Okay, I'm going to stop there for a minute. Okay, this time we're going to do one that opens up or down. This time they give it to you in the standard form, y equals 2 times x plus 7, quantity squared plus 3. So they already gave it to you in the right form. I would write the beginning equation down, y equals a times x minus h. And people, part of the reason I'm asking you to write those equations down, the more you write them, because we're going to do parabolas, we're going to do circles, we're going to do ellipses, we're going to do hyperbolas. The more you write these equations down, the better. Okay, and then plus k. Okay, so on this one, the vertex on both forms is hk. On this form, the h is on the inside. It has to be a minus sign on that formula. So the vertex is -7, 3. Okay, the axis of symmetry is x equals h. So x equals -7. Okay, so we know the vertex, we know the axis of symmetry. How does this open? Yeah, because this a equals 2 and a is greater than 0, so it opens up. Okay, the focus is h and then k. Okay, so the focus is h over k plus 1 over 4a. So the focus should be -7, 3 plus 1 over 4 times 2. So -7 plus 3 and 1/8. And I can write it 3 and 1/8. And don't go to decimals, just leave it in fraction form. Reduce your fraction. So that's your focus. The directrix is y equals k minus 1 over 4a. The k is 3 minus 1 over 4 times 2. So 3 minus 1/8. 2 and 7/8. So the directrix is y equals 2 and 7/8. Okay, and then we need the length of the lattice rectum. Okay, and it's the absolute value of 1 over a. So the absolute value of 1 over 2, so the length is 1/2. Okay? Okay, now let's graph it. Okay, with the information we've got. Okay? Okay, so first we know the vertex. The vertex is at negative 7, 3. Negative 7 and 3. And that's our vertex. X equals negative 7, so x equals a number is a vertical line. And we know it opens up. The focus is negative 7 and 3 and 1/8. Really tiny difference between the focus and the vertex. Y equals 2 and 7/8. So there's right below here that y equals 2 and 7/8. So there's only an 1/8 of a difference between the vertex and the directrix. This would be the directrix at y equals 2 and 7/8. This one is the axis of symmetry at x equals negative 7. Okay? And then we know it opens up. And we know from the focus, this one is actually the vertex and this one's the focus. From the focus, the length of the lattice rectum is 1/2. So it only goes like a fourth over here and a fourth over here. And then it opens up. So at no point am I really asking you to make a table of ordered pairs. Okay? But you should be able to check your graph on the ones that are y equals. Okay, so let's check.